Good afternoon, everybody. Welcome to our fourth acid-base lesson. Today we're going to be talking about titration and doing some practice problems with titration. And then I'll have some announcements, I guess, at the end to talk us through. First, let's recap a little bit. Right, we talked about acids and bases. We defined acids and bases. We talked about how an acid is something that gives H plus or makes H plus. And then we talked about a base, and a base is something that makes OH minus or accepts the H plus that is offered to it. Right, we talked about pH and how we measure pH, and it's a measure of how much H plus there is or how little H plus there is, right? Kind of a ratio of the H plus to the OH minus. If there's much more H plus, we have a lower pH. If there is more OH minus, we have a higher pH. Water in the exact middle of the pH scale because it is equal parts H plus and OH minus. Then we went on to talk about neutralization and how when we have something that gets neutralized, we have something that has the H and an OH coming together to make water, canceling out the acidity and the basicness. I've decided to use basicness instead of basicity because I'm not sure if basicity is a real word. Today we're going to talk about titration. Titration is the process of doing neutralization in real life, which is ironic for me to talk about here because we're probably not going to get a chance to do titrations in real life. We know that a neutralization is something where the H... Nope. Hey now, not what I wanted to do. We know that titration or neutralization is something where the H plus is going to be equal to the OH minus, and they're going to cancel each other out. Right? Canceling out to make water. The process here, right, the process of H and OH canceling out, this is neutralization. And that's what we talked about yesterday, where we want H plus and OH minus to equal, canceling out to make water. Titration is doing neutralization in real life. And it's a process for when we're standing in the lab actually doing a neutralization. Are we going to have makeup labs? Maybe. Honestly, not sure. It depends on when we get back into school, right? Because I can't really give you anything to do at home that I trust you with. So we'll see what happens. Titration, again, is the idea of doing neutralization in real life. We're calculating out the molarity and the volume of acids and bases that we're using to cancel each other out. Instead of what we did yesterday, which was finding the amount of H plus we need or the amount of OH minus we need, we are going to kind of approach it from a different standpoint where we're going to say these two things have canceled out. So how much did you use, or how much molarity was there? Right, we're going to tell you that these things have canceled, and you're going to go backwards and tell me how much there was. The goal, right, of a neutralization is to get it as close to the neutralization as possible, trying to get to 7. By real life, I mean if you're actually mixing together acids and bases. If I had an acid in my hand and a base in my hand, I would titrate them to neutralize, cancel them out. I will give examples in a second, yes. Yesterday, we looked at a neutralization. I said if I have 3 moles of HNO3, then I would need, if I've got 3 moles of HNO3, how many moles of NaOH do I need to neutralize it? Right, and this was on the, this is what we were talking about yesterday. This was neutralization, and it's saying 3 moles of acid, you need 3 moles of base. Right, so our answer here is 3 moles. Right, see how they're asking us how much you need in order to actually do a neutralization? For a titration, I'm gonna say thing X and thing Y neutralize. They cancel each other out. And then we're gonna work backwards and use this formula that is on the reference table to get to the point where we can then say how much there was instead of us looking at just moles. It's a little bit more practical. Nope, again, stop, not what I want to do. There we go. So, examples. In a titration, what you're doing is you're saying 50 milliliters of 1 molar HCl were 50 milliliters of was neutralized by 100 milliliters of NaOH solution. What is the molarity of the NaOH? Ooh, what an ugly thing I drew there. Let's try that again. So they're telling us from the start, and I get to do this again now. Right? They're telling us from the start that this was neutralized. So we already know that the moles of H plus are equal to the moles of OH minus, right? They tell us that that is a fact. But what they don't tell us is how many moles of H plus we have and how many moles of OH minus we have. What we're going to do is use the formula that is given to us on the reference table to go back and calculate for the missing thing. Molarity, right? No. Sorry. Molarity, taking full advantage of my colors, right? We know that molarity equals moles over liters. So if I have molarity times volume, I have moles, right? If I cross multiply to get moles by itself, molarity times liters equals moles. So what this formula does is it tells you the moles of H plus and compares it to the moles of OH minus. By taking molarity times volume, you get moles of H plus. Molarity times volume, you get moles of the OH minus. Right? We have them labeled as MA, molarity of the acid, volume of the acid, molarity of the base, volume of the base. Right? So it's not just like substance A versus substance B. It's not like when we were looking at gas laws and we had P1V1 over T1 equals P2V2 over T2, and it was just a before and an after. Here it's specifically acid and base. And so if I want to plug in to look at this here, I have, going back to my green, the molarity of my acid. They gave it to me in the problem. It's 1 molar. The volume of my acid is 50 milliliters. I want to know the molarity of my base, so that's going to be my X. And I know the volume of my base, 100 milliliters. Right, solving through for X, I'm going to get 0.5 molarity is going to equal X, just like a bunch of people said in the comments before. Right, it's not necessarily a more complicated thing than the stuff we were doing yesterday. It's just a different version of neutralization. It's looking at it from a different standpoint, not just asking you about moles, but specifically giving you 3 of these 4 things and asking you for the last one. Right? So they gave me my molarity. They gave me my volume. They gave me the volume of the base. And they asked me to solve for the molarity of the base. Right? So Serena asks a question here. 1 molar HCl is 1 molar H+, and that is correct. Remember when we looked at that in our previous unit we talked about, so for example, 1 molar NaCl is 1 molar Na plus and 1 molar Cl minus. Alright, so it's the same thing here, except I'm looking at HCl, so it's 1 molar H plus and 1 molar Cl minus. We care a lot more about the H plus than the Cl minus. It's there, but we don't really... it's not going to play a factor in this. This is on the reference table. It's on the very back. It's titration. It's near the bottom, if not one of the very last things. It gives you this formula in black. I'm pausing here for questions, comments, and or concerns. If it's blurry for you, it's probably buffering. So correct, we are not using the molarity formula for a question like this. We're going to plug in our pieces into this formula, yes. So it's not using the molarity formula directly, but the molarity formula is where this was made from. Is this specific to titration? Yes. If you look on table T, it is the titration formula, right? And then it gives you, with my beautiful straight lines, like it tells you this straight up on table T. Right, so it's not a difficult formula to use. It's not particularly complicated. There's really not a whole lot they can mess with this formula, right? They have to give you volumes. They have to give you molarities. They won't ask you to find the titration, right? They'll kind of word it pretty much the same way that I've worded the question here. They'll say the right volume and the molarity and the volume or the molarity of the second one and ask you to find the missing piece. It's about recognizing what pieces they have given you and what they're asking for and knowing that this is the formula that connects all 4 of those things together. When we were going to do this in class, we were going to have a lab where we actually titrated. Instead of that, I'm kind of just going to walk us through the process. We are going to it's a real slow and careful process to titrate something, to neutralize something in the lab. It's about carefully adding the acid to the base and then more base to the acid and back and forth until you hit the exact perfect middle point, until you've neutralized your acid and your base. And then using the readings that you get off of your instruments, you can then calculate with the formula that we just saw. Do I have to write this slide if I'm taking notes? You don't have to write anything down, ever. You write what you want to write. I'm going to go forward. If you want to copy this down, pause the video or go back and pause the video and leave some space, but I do want to just draw this process out. And so I'm going to do some pretty crude drawings here. We've seen burettes in the past. Ooh, baby, that's a straight line. What a beautiful straight line we have here. All right, we've used burettes in the past. They were these really tall, thin glass tubes labeled on the sides with volume, and they had a little spigot at the bottom that let the liquid come out. In a titration, you have two burettes. Oh god, that's really bad. In a titration, you have two burettes, one for your acid and one for your base. Right, with their little spigots and their lines all the way up the side. Right, they're way thinner than what I'm drawing here, and they also look way nicer than what I'm drawing here. So you have acid and you have base. All right, you have filled the acid and the base up to the tippy top, to the 0 line. All right, all filled with acid, all filled with base. All right. The idea here is that you are going to, in a flask, combine some of this acid and some of this base until you have neutralized it. And in order to see when that is done, we're going to use indicators like we talked about the other day. We're going to take some of this acid, that's way too much of the acid, and we're going to take some of the acid and put it in. We're going to put a little bit of indicator in. Remember, the point of an indicator is that it changes color. All right, it's going to change color as the pH changes, so we're going to put a little bit of indicator in there. We're going to slowly add base to the solution until we see the color change that we want. Right, we added a little bit of base. We add a little bit more base. And we wait until we see the color change that we're looking for. All right, the whole thing changed color, hooray. We've hit our neutralization point. Does the type of indicator matter? 100%. Because indicators change color at different points, remember table M? Right, we have different ranges for different indicators. So for a titration, most of the time, we're going to use phenolphthalein. because it has a range, a color change range right around neutral. And so we'll see it go from clear to a wispy pink as the solution gets neutralized. Then, right, now that we've neutralized each of these pieces, or we've neutralized the amount of acid and base, we're going to take a measurement. Right, we're going to say, well, this is 15 milliliters. This is 20 milliliters. And we can actually... this is the process of the lab that we would have done in class. Yes, I also, to be fair, would have done this whole presentation and this whole drawing for you out on the board in class before we got in there, just to show you what we were supposed to do. But we would have then followed it up with a lab, yes. So we have now, if we're looking at our formula, we want to MAVA, MBVB. We have our volumes, so we have 15 milliliters for our acid. We have 20 milliliters for our base. And one of these would be a known quantity. We would say that this is 1 molar acid and mystery molar base. Right, so we would have plugged in then our last piece of information and solved to find X. The 15 and the 20 represent volume. And so we would have things that we then solve to find X, which is going to be 0.75 molar base. One of them is told to you, right? So these two things should have been known from the start, right? We know the concentration of the acid, we're looking for the concentration of the base, and this is what we would do in order to find it, right? The idea is, right, Johnny walked into the chem lab room and sees that there's an unlabeled bottle on the shelf. He tests it with litmus paper, and he sees that it is a base. He does not know what the concentration is, so Johnny titrates the base. If these are his results after titration, what is the concentration of the base that Johnny found? And it would give you this whole backstory and this whole idea of like, well, we have this mystery thing. Johnny finds it. He wants to know what the concentration is, so he does this whole process. And now he can slap a label on this base and say, well, I know it's base. I know it's 0.75 molar base. Should call him George next time. Curious George finds an unlabeled base bottle. When it comes to actual questions, right, we're going to see much like we saw before. Oh, too far back. We're going to see questions worded this way. And we're going to have a little bit more calculation and a little less storytelling. But again, it's all just taking the values from the problem and plugging them into our formula. If you know the titration, does it help you find the name of the substance? No, it does not. Because we know that this is 0.75 molar base, but do we know if it's NaOH? Do we know if it's NH3? Do we know if it's CaOH2? Right, we don't know any of these things. Right, we have no idea what the actual substance is, but we know the concentration of the OH minus that's there. Right, when we look at questions for this, we're going to see them worded kind of like this. They're going to say the word titrate more often than not. They'll use the word endpoint, or they'll say neutral, right, somewhere in the question, right? This one doesn't say neutral, but it says endpoint, it says titrate. It gives you these hints about the fact that we're supposed to be canceling out an acid and a base. They gave us a volume, they gave us a molarity, they gave us a volume, and now they're asking us for concentration of the acid. Is titration a verb? No, titrate is a verb. You titrate a thing. Titration is a process. To titrate is the verb. Right, but now they gave me clues in here that this should be a titration. Right, they gave me the word titrate. They said endpoint. Right, these things are going to be the clues that I'm supposed to plug into my formula, which again I get off the back of the reference table. MAVA equals MBVB. They gave me 60 milliliters and 1 molar base, so 60 and 1. All right, milliliters here, molarity here. They're asking me for the concentration of the acid, and they told me 1 liter. 1 liter means I need to change this to 1,000 milliliters. Right? It doesn't matter what units you use as long as they are the same on either side. When I solve this out for x, it'll be 0.06, which is going to be choice 1. And that'll be our answer there. In real life, the color change begins right at 7. For phenolphthalein, the reference table is a little off. And we see the change happening more around 7. The slight starts to change to pink. That's not a sentence. The color starts to very slightly change to pink right around 7. So that's why we're aiming for the very, very wispiest pinks we can get. Here, right, we took our 2 pieces. Units are our tricky part. It's always going to be molarity for our concentration. But our volume units can change. We just need to make sure that we remember the fact that 1,000 milliliters are equal to 1 liter. If we looked at another one, right, what volume of 2 molar HCl is needed to titrate a 1/4 liter of 4 molar lithium hydroxide to its endpoint? Again, they gave me clues. Right, they're asking me about a titration. They're saying endpoint. Right, they're giving me clues that I'm supposed to use a titration formula. So when I plug in here, I'm going to have MAVA, MBVB. What volume of HCl? So that's X, 2 molar. That goes here. 0.25 liters, 0.25. And 4 here. When I solve this out, I'm going to get X equals 0.5 liters, but whoa, none of these choices are half a liter. But wait, it's this one. Because remember, 1,000 milliliters is 1 liter. So 500 milliliters is half a liter. Are they always going to say neutralize or titrate? Yes, they should be giving you one of those 2 words or something along the lines of endpoint. Or, yeah, they're going to say something along the lines that should clue you in right away to this formula. And again, our answer here is 1. One of the trickier things that can happen here is having a multi H plus base, right? So a diprotic acid. Here we have still a titration, right? They're still saying all of the key words that clue you in. They're saying titration. They're saying endpoint. But the funky thing that's happening here is that this is 2 H's for the price of 1. So instead of 1 molar acid, we have 2 molar acid. So this needs to adjust because we want the H plus. So we're gonna, when we plug into our formula, MAVA equals MBBVB. We're gonna plug in 2 molar for our concentration of acid because there's 2 H pluses here, and then again 500 here, X, and 1000. When we solve this out, we're going to get choice 3, which is going to give us 1 as our answer. Right, the same thing can happen with multiple OHs. In that case, we would make the same adjustment, right? If we had 2 molar calcium hydroxide, we would have 4 molar OH minus, right? Because it takes into account the number of OHs that we have. Right? And if you look on the reference table, if you look at table T, when it says MA and it defines what that is, it's the molarity of H plus. And same thing with MB, it should be molarity of OH minus. Right, so we're counting the H pluses and the OHs and taking them into account. Because we need, remember, the whole idea behind this is a neutralization. And a neutralization, the whole idea is that H pluses are going to cancel out OH minuses. Right, so it doesn't matter how much of H2SO4 we have. We don't care about H2SO4. We care about the 2 H pluses that are in every H2SO4. Can H2SO4 be simplified? No, because you cannot reduce the S. So if I have H2S1O4, I would need to be able to reduce all of these to make it more simpler. And I can't reduce past a 1. Right, I think I got one more in here. Yeah. Alright, so exact Regents wording now. Again, look at the clues that they are giving you. Completely neutralize, 40 milliliters of solution, and look at the information that they are handing to you. Right, they're giving you a volume, a molarity, a volume, and they're asking for the molarity. So when we're plugging our things in here, we've got, sorry, you can change my font color again. We've got MAVA equals MBVB. We've got 1 molar HCl. We've got 20 milliliters. We've got X, and we've got 40. Solving this out, we're going to get choice 1. I'm going to try that circle one more time. We've got choice 1 with half molar. they have to tell you that it was neutralized, because you don't know how to solve for it if it's not neutralized. You can't set them equal to each other if they don't tell you that there was a neutralization that happened, or they don't say that it was titrated. Right? Because this whole thing is working on the idea that moles of H plus are going to equal moles of OH minus. And so if they tell you it's not neutralized, then the only thing you know is that it's not whatever you solve for X. Oop. Right, so if this question said not neutral, any one of these things could be the answer, but the only thing you know is it's not choice 1, because choice 1 would fulfill this equation. But they're not going to ask you that anyway. Nope, stop that please. There we go. Right, that wraps up our acid and base unit, actually. Surprisingly quick, without actually being in the classroom for some reason. I have no idea what we're going to do about quizzes and or tests. I'm going to figure that out most likely tomorrow, and send an email out that way. There will be no live lesson tomorrow. I'm going to come in and just do office hours and tutoring at roughly 1:30 instead of having a lesson, and then I'll think of something over the weekend and announce, or think of something tomorrow and announce for us to do in terms of tests, quizzes. You should be able to do the homework. A bright idea, and you don't have to take my word for it, would maybe be try to do the homework, and then if you have any questions on it, come to office hours or tutoring tomorrow and ask a question. Maybe that would be a helpful thing. I don't really know, though. Yeah. So I'm going to end this here, transition it to office hours and tutoring. Please, please, please keep an eye on your Pupil Path emails and Google Classroom. I'm probably going to make an announcement on there about either the structure of the week or our tests and quizzes. I'm thinking of either doing a test or a quiz next week. Again, I don't want to move too far away from it. Tutoring is on here, right? It immediately follows all of the lessons. So I'm going to stop this stream and then start up another one for about 20 minutes to answer any questions that people have. Yeah, and I'm going to repeat myself again. Please keep an eye on Google Classroom and on your Pupil Path emails, because I'm going to make an announcement. I'm going to post the same exact thing to both places. Sorry if you get it twice, about tests, quizzes, and the rest of our weeks moving forward. See y'all later. Stick around for tutoring if you would like it.